Hello everyone, I'm RJ, FAE of Nuvoton Technology. Today I will introduce Nuvoton NuTool-LCDView, a visual LCD application development tool. NuTool-LCDView is a powerful tool that can generate LCD configuration code and get real-time emulator COM status. LCDView can help engineers finish and debug LCD projects easier. So here is the agenda for this section. I'll focus on showing you why we need this tool from the perspective for the development process and tell you what features and functions it has. And we'll also show you how to apply in a COM LCD project step by step. So first of all, just one question. Have you ever encountered any challenges while developing LCD project? From the LCD development process viewpoint, it's a sequential flow path. The process started with designing the LCD screen by UI/UX engineers, and it was then made by an LCD factory. While LCD specifications are locked down, it's the hardware engineers' turn to design and prepare hardware, and meanwhile, firmware engineers can start to work. However, during this process, people will encounter three problems. First is that UI/UX engineers have no references and no actual LCD screen view to know what it would be like. Thus, there are many uncertainties in the planning stage. The second and the third problems are for firmware engineers. It always takes time to set the COM register, and moreover, it's also challenging to debug before getting an actual LCD device. Thus, you might think that if there is a tool that can synchronously display the LCD view on the PC with just some easy setting up steps, it can help improve any uncertainties, such as emulating the LCD effect before getting the actual device. So during this process, firmware engineers can join the planning stage and develop the firmware part at the same time. Then they can connect and bring it up while the LCD device is ready. So that is what NuTool-LCDView can provide. Furthermore, to accelerate users' development process, NuTool-LCDView supports users to emulate the result in real time while switching to emulator mode, which meets the requirement for users who need to emulate LCDView on a PC if the LCD screen is not ready. And otherwise, LCDView is a user-friendly and flexible tool that makes engineers finish job easier. It will avoid making mistakes in the evaluation stage, which always wastes much more time and cost while fixing the fault. So to summarize the power of this tool, it will become multitasking in the viewpoint of the development process. LCDView can show the effect in advance, and firmware design is working simultaneously, which is good for UI/UX and firmware engineers. And because it is visible, customers can modify it easily before LCD enters the manufacturing stage, which means that firmware has almost done everything before getting an actual device. So guess that you might feel excited and want to know more details. Let's take a look at the features of LCDView. LCDView has Create Mode and Emulator Mode, which are for editing projects and emulating results respectively. Users must finish all the setting of LCD and COM table under Create Mode. In Create Mode, users can adjust customized settings easily, such as LCD panel size and the amount of COM table. And meanwhile, LCDView has a rich icon database, which supports users in adding their icons in easy steps. As for the COM table, users don't need to worry about mapping with an MCU pin. LCDView combines NuTool pin configure. Users can import the pin configure file to show the pin number on COM table. And after finishing the design, LCDView will generate a header file corresponding to the design. And in real time, users can connect to MCU and show the design result under emulator mode. LCDView can read every concept status and real-time show on PC. Otherwise, LCDView has a standalone version and plug-in Cloud IDE and IAR IDE, which can support users checking effects using single-step debug mode. And in this way, it helps every designer and engineer see the results before getting an actual device to avoid any uncertainties. As for the supported chips, currently, we support several Nuvoton product series, which have LCD driver functions. One is ARM Cortex-M23 based for M254, 256, 258, and M2354. And other series are the A051 based, which is ML54 and ML56 series. For those COMSEC LCD series, Nuvoton provides a NewMaker evaluation board with the COMSEC LCD panel sample, which can be used as a standard template for project evaluation, functional development, system verification, and power consumption monitoring. If you need more information or you want to buy it, please refer to the Nuvoton website. So now let's take the NewMaker M258KG evaluation board for a simple practice. There are 4 steps for finishing a COMSEC LCD project using LCDView. The first step is preparing hardware and software. The second step consists of importing the pin definition with the pin configure tool and editing LCD canvas and COMSEC mapping, and exporting the header file. The third step is coding. Nuvoton provides BSP and example code, so users need to do a few modifications to finish this part. And last but not least is about running and debugging. Under emulator mode, users can debug in Kyle IDE and see the effects on the LCD panel and PC. Let's talk more about each step. For the preparation part, we take NewMaker M258KG for example, and a COMSEC LCD panel, whose part number is TNLCDSUB_M258K. So you can find all the hardware documents on our website, such as the schematic, Gerber file, BOM, etc. As for software preparation, we need 3 software tools in this practice. Include LCDView, Pin Configure, which is used to config pin, and NewLink Kyle driver, used to support the plugin Kyle IDE version. So here is each download path on the Nuvoton website. If you already have the Pin Configure tool and NewLink Kyle driver, you have to notice the software version is the latest. So let's download the LCDView tool together. Please enter nuvoton.com and click Software and Tool, find Software Tool directory. LCDView is under the application-specific item, so click it and you can find the latest release LCDView. Just download the first zip package and extract the package and open the NuTool-LCDView. So after executing the LCDView tool, you will see the screen most like this. Let's take a look at the primary user interface. So in the upper left-hand side of the screen is a switch for changing into create mode or emulator mode. And about file icons, users can save an LCDView project as an .mvt file. And of course, you can load the project. And meanwhile, LCDView supports loading the file from the Pin Configure tool. To use this one, it will automatically map the COMSEC table to the MCU multifunction pin. And after finishing all designs, user can generate a header file directly by clicking this BSP icon, and the default name is lcdzone.h. LCDView provides some basic icons for designers. User just drag and drop to edit the canvas. And user can also add their icons by loading specific icon files. And at the bottom of the screen is COMSEC setting table. User just need to click the corresponding icon and COMSEC. Then they will finish the mapping. So after the introduction of the interface, let's enter create mode. So just open the NuTool Pin Configure tool and setting pin configuration according to the schematic file. And save the pin configure file as .cfg type. Then back to LCDView, choose the chip series and part number first, and click the pin configure icon and load the .cfg file into the LCDView tool. And after loading, you will see the pin you configure automatically mapping to the COMSEC table. For example, COM0 here maps to pin 1. Then you can edit the screen on the canvas. Just drag and drop the icon you want from the database to the canvas. And at the same time, according to the LCD specification, just click and set the icon to the COMSEC table. And if you need to group multiple icons, for example, I want these 3 7-segment displays to be a group. so name them as the same group name. So turn as an example here. Then, while using the LCD API, this group will light together. I will show the API using method later. Then finish the rest of the canvas in the same way. So if you finish your design, just click this BSP icon and it will export the header file called LCDZone.h in default. This header file already helps users finish the LCD firmware definition. And the next step is coding. First, let's see how to use BSP. So just download M251BSP on Nuvoton's GitHub and extract it. And find the LCDZone.h file and replace it with the one you generated from the LCDView tool under the library directory. Next, follow this path to open the LCD_blinking sample code. Here we use Kyle IDE as an example. Open the main.c under the user directory. We can separate main function into two parts. The first is about system initialization, and second is the workflow of LCD blinking. About system initialization, remember to open the LCD module clock. An LCD blinking workflow consists of LCD pin initialization, setting the LCD contents, and enabling the LCD to display. In LCD init function, you need to configure all LCD pins and set LCD related parameters such as frame rate, duty, bias, voltage, etc. And these parameters are defined as global structures. And you can use the LCD enable blink function to set the blinking frequency if you want the blinking effect. Next, use LCD_lib_printf function to set specified text on the LCD. The first parameter in this function is the group name defined in LCDZone.h file. And the second parameter in this function is the string you want to show. And otherwise, we also provide another 3 APIs. You can find the related function description in LCDLib.c file, including print number, put chart, and set symbol. At the end of the LCD setting, use the LCD_enable_display function to enable LCD blink. Then we can compile and run projects now. We need to connect the evaluation board to the PC. Use a USB cable to connect NuLink to Me USB connector to the PC USB port. And then back to Kyle IDE. Click the Review button to compile. After compiling successfully, click the Load button to load the program into MCU. Then the LCD will show the result. Last but not least, the most significant feature of LCDView. Let's look at how to use emulator mode and how it helps with debugging. After a project is built, click the Start Debug Session button to open the debug mode. And from the items of debug, click the NuTool-LCDView. If you cannot find this option, please ensure you have downloaded the NuLink Kyle driver. Then you can see the LCDView window and click the Do project icon and do the NVT file your project apply. And switch to the emulator mode. And then click Step in Kyle IDE, and LCDView will show the result in the window. This function greatly helps engineers because they can check the code before getting an actual device. That's all for this tutorial. Thank you for watching and welcome to subscribe to our channel. If you want to get more information, please contact us.